And we are going to look at patterns today. So we're looking at algebraic sequences. Big load of exam questions on this. So in foundation and higher papers, you'll definitely see this. It is on there every single year. So we're going to look through a wide range of questions. I'm not going to go too high up to the high, so it's going to be a lot more what you might see on foundation, but these questions might be at the start of potentially a higher paper, okay? So do leave me a comment as well, so just here, so ask me to any conversation you want, and I can answer hopefully any questions you might have, okay? So, right, let's crack on. So first question here, it says the first five terms of a sequence, okay? It normally always says this. I'll show you how I can get a bit harder in a sec. 2 marks. So it's not much working out you might have to do. So it goes 2, 4, 7, 11, 16. And you can clearly see it's going up in threes, okay? Write down the next 2 terms of the sequence, okay? Next 2 terms in the sequence, we can clearly see it's going up in threes. So it's going to be 19, and then 19 plus 3, that is 22. So you can clearly see that's, one of the easiest questions, okay? You don't have to be, really, really good at maths to see that. That's quite a basic one. That's the easiest it can come. Right, let's step it up a little bit more and see how much trickier it can get. I'll go a little bit further down here. Better look. So the first term in a sequence is 3. So I'm writing that down. The first term, okay? That's the first, right? The term rule is add 5. And what that means is it's telling you that it's going up in 5s every time. The rule is add 5. So then 3, I'm not even seeing what the actual question is yet, but just to show you, add 5 is, so that'll be 8, and then add 5, that'll be 13, and so on, okay? Is 97 a term in this sequence? Okay, give a reason for your answer. There's a couple of ways you can do this. I'll show you the more algebraic way in a second, because you'll see that on more of the other questions. However, you might see a pattern. So if you just keep going up in your 5, so 13 plus 5 will be 18, then 23, and then 28. And you can clearly see here, it's going, ending in a 3, ending in 8, 3, 8, 3, 8, 3. So you can see, you can write a sentence basically saying, number ends in 3 or 8. As long as you've got something that kind of explains the pattern, because you can clearly see a multiple of 5 is not going to come up in that pattern at all, okay? Right, here are the first 5 terms of a Fibonacci sequence, okay? So the first 5 terms. So 1, 2, 3, 5, 8. Right, this one, you really have to know what a Fibonacci sequence is, because if you try and work it out in the exam, you might get a little bit stressed because it can be a bit, it's not a clear pattern unless you've seen it before, but most people have seen this, and I always teach it to my students. So what a Fibonacci sequence means is not always this, it can be anything. These are typical, the original one, which sometimes use. But all it means is you add these 2 numbers to get the next number. You then add these 2 to get the next one, add these 2 to get the next one, and so on. So basically, this number is a sum of the previous 2 numbers. So 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, and so on. So the next 2 terms, so I do 5 plus 8 is 13, and then it'll be 8 plus 13. So to get that one, that was 5 plus 8. And to get the next one, you'll be doing 8 plus 13. So this one then will be 8 plus 13, which is 21. And that's it. 2 marks. So you get a mark for each one you get. Same with these ones. You only get a mark for spotting the pattern or one of the numbers it wants. Right. The nth term of a sequence. This time, it's gone straight a bit more algebra now. It's giving you a rule. And it basically means it's a 4 times table, but you're going to add 3 each time. So 4 times table, and you're adding 3 each time. So the first 2 terms of this sequence. So the first number, so I put the numbers in order like this. So it'll be first number, second number, third number, fourth number, and fifth number. So the 4n, that basically means the first number in the pattern, that's what n means. The n refers to the position of each term in the sequence. So to get the first term, you do 4 times 1. Second term, 4 multiplied by 2. third term, 4 times 3, and so on. So I'm not going to do this for every single question, but just to show you the 4n, so that'll be 4, 8, 12, 16, 20. So the 4n is the 4 times table. Then the plus 3 is when you're then adding 3 to each of these numbers. So that'll be 7, 11, 7, 11, 15, 19, 23. Yeah, so then you can see this actually goes up in 4s as well. Yeah, and that's all it means. It's a 4 times table, but you're adding 3 each time. So to get this number, it'd be 4 multiplied by 1, add 3, 4 times 2, add 3, 4 times 3, add 3, and so on. And that's all it is. Right, let's take it up a little bit. Should be quite a shortish one today, so it's not going to go on too long, this one, but I'll try to give you a wide range of questions so you really see a lot of different types of questions as well, okay, what they could throw at you. So, like this one here, we've got n squared, so it's going to involve some square numbers. And so I wonder what that could be. Right, so find the first terms of sequence. It's basically saying you get the number, you square it, then you add 1. So to get the first number of this sequence, you're going to square it, then add 1. So like before, the n squared, first number, second number, third number, fourth number. So you square numbers, 1, 4, 9, 16. The plus 1, which is this bit, you're then going to add 1 to each of those. So n squared plus 1. So add 1 to this one, that'll be 2, 5, 10, and 17. So the first two terms, and I've done more than that just to show you, first two terms will be 2 and 5. That's it. So that is part A right there, done. Right, B, is 35 a term in this sequence? A few ways you can do it. Easiest way, I would say, is just go up the next couple of terms because you're going to go past it. Especially if you know your square numbers, you know what you're looking for. So the fifth term, so 25 is your next square number. You add 1 to that, is 26. The next square number is 36 because 6 squared is 36. Then you add 1 and that is 37. So you can see, is 35 term in the sequence? The answer is no. Yeah, because them terms close to it are 26 and then it goes to 37. So you can clearly see 35 is not a term in the sequence. 2 marks, job done. And I think it's literally a mark for each question. Okay, so question 6 then. Have a look here. First 5 terms of sequence. 17, 14, 11, 8, and 5. So this is question 6. And they're not necessarily in order, like goes 6 to 9. They're all past exam questions that I found online to throw them all together. Yeah, so all at different points in an exam. Like this could be question 5 in an exam one year, then question 8 another year. Yeah, it changes all the time. Typically though, the harder this question is, the further into the exam it will be. Okay, the harder this question is. Right, next in a sequence. So you can see it's going down. And you can see it's going down in 3s. So it's going subtract 3, this one, subtract 3, subtract 3 every time. So the next term of this sequence, we're going to be doing 5, you can see there, minus 3. Okay, 5 minus 3, so the next term is 2. Yeah, quite straightforward. Right, the nth term of a different sequence, so this question is actually separate from that one. It doesn't, not necessarily, it's part B. You know, part B doesn't necessarily always involve part A, okay? So there's a separate one. Work out the 5th term of sequence. So the nth term of different sequence is 10n squared plus 5. So it's checking, do you know how to substitute this number into that formula? Well, expression is given you because it's not going to equals on it, it's an expression. So the 5th term, so all we're going to do, we're going to substitute that n for this 5 here. So we're going to go 10, so it'll be brackets 5 squared plus 5. The brackets, you can just multiply there. It doesn't really matter, okay? So 10 multiplied 5 squared isn't, don't say 5 squared is 10. It is 25, okay? So 10 multiplied by 25 plus 5. There you go. So 10 times 25, 250 plus 5 equals 255, okay? So when you break it down, it's really not too bad, these questions, are they? Yeah, they're quite straightforward patterns. Obviously, they can go a lot harder. Right, I'm going to quick little sip, my drink. Have a look at that question there, Fibonacci sequence. See if you can remember that one from the previous question we just did. Right then. So first 5 terms of a Fibonacci sequence. So it's slightly different to before. It's not always the same one. Obviously, the original is, his original Fibonacci sequence. You can Google that and find that out yourselves. However, Fibonacci just generally refers to a type of pattern. So, hopefully you've seen from last time, the Fibonacci sequence, basically, the previous 2 terms add together to make the next term. So, 2 plus 2 is 4, 2 plus 4 is 6, 4 plus 6 is 10, and so on. Find the 8th term of this sequence. So, don't worry about trying to find a formula when it's Fibonacci. It's not going to give you this pattern and ask you for the 200th term. Okay, you're not expected to know the nth term involving a Fibonacci sequence. Yeah, because it's really challenging to find that out. And it isn't on GCSE at all, or even A-level, as far as I know. You may give you a formula and you've got to substitute numbers in, but they're not going to do that. Yeah, it's highly unlikely. So that's why that is quite a low one, and you can find it out. You've got 5 terms. So what will the next one be? So we're up to 5. The 6th one's going to be 6 plus 10, which is 16. Then it's going to be 16 plus 10, which is 26. So to clarify, we've got that one. That's 6 plus 10. To get this next one, that is 10 plus 16. And that's how we got that one. Job done. Okay, right. Next one. Right, patterns. So sometimes you like to throw in pictures for you as well. Okay. Here's a sequence of patterns made from white tiles and grey tiles. Hopefully you can see that here. You can see slightly shaded ones there, the grey ones. Okay. 3 patterns. Yeah, I knew this was going. Sometimes it says draw pattern number 4. Pretty standard question. I mean, clearly see here, it's 1 grey square, it's 1, 2, then 4. So it's going to look something like this. I'll do it down here because it's got more space. So it's going to be 4. You don't get marks on your artistic ability, okay? So it doesn't matter. As long as it's fairly equal, it is fine. So that's going to be something like this. However, I would shade it. It doesn't have to be perfect, but as long as you can clearly see what is going on. Yeah, you can clearly see that is an extension of that. Okay, that is pattern number 4. Right, that's part A. Part B, work out the total number of tiles to make pattern number 7. So this is actually easy than you think, really. I wouldn't bother drawing it. You can draw them if you want to, but it's just going to take you more time and a lot more effort, okay? I would, because it says total number of tiles. Yeah, total, the keyword here. It doesn't want specifically grey or white, just total. So count 1, 2, 3, 4. So you see it's 4, then that'll be 4, 3, 7, then 3, 6, that's 10. So you can see it is going up in 3s, okay? So then to get pattern number 7, we'll know it's going 4, 7, 10, 13, so I'm up to 4 now. 16, that's the 5th one. 19, and then 22. 1, 2, 3, 4, 5, 6, 7. So it's going to be 22. Right. Try not to overcomplicate these questions, okay? Sometimes read the question, read it over again. All right. Question number 13. Here are the first 5 terms of a sequence. 31, 27, 23, 19, and 15. So you can already see it's going down, okay? And we can see it's going down in 4s. Okay. Right. Find the first negative term in this sequence. I don't know if I said negative really weird then. Find the first negative term in the sequence. So in this instance, I will just keep going down. It's on 15. It's not going to be many until you get there. So it's going down in 4. So keep the 15, put that here. Go over here, make sure you can see. Do let me know in the chat if you can't see. Going down in 4. So 15, 11. And take away 4. That'll be 7. And 3. And then -1. So you can see -1 is the first one. So it's -1 is the answer. Right. Is -30 a term in this sequence? So you might have seen the pattern already, but we can keep going and hopefully you'll see it a bit more clearer. Okay, so -1, the next one. You could keep going to prove it. So -1 and it goes -5, then -9, -13, -17. Right. You can see already -30, that'll be in the 10 times table. Yeah, if you go back. So you can clearly see none of these numbers are in the 10 times table. So you can see, so no numbers end in a 0. Yeah, and you could, just to be safe, you can go back and clearly show that it isn't going to be there. It goes to minus 29. Yeah, and that both those will be fine. That'll be fine to justify it. 3 marks, nice and easy. Right, let's move on. Last couple of questions now for this live stream. So let's have a little read. First 5 terms of an arithmetic sequence. You know, arithmetic, another way to say it, arithmetic. Basic general arithmetic means just working with numbers, you know, your basic operations. In a sequences sense, arithmetic means the number consistently goes up or down the same amount each time. So it's either adding, for example, adding 2 every time, or subtracting 2, or adding 5. Yeah. There's other type of sequences such as Fibonacci, geometric, where it's multiplying or dividing, and it's not always the same amount. Whereas arithmetic, you know, it's always adding or subtracting. In this case, it is adding 4 every time. Yeah, you can see adding 4, add 4, add 4. Yeah. Clear. So I always make notes, encourage my students to make notes when going through questions, because that can just help you realise what you need to do. So it's adding 4 every time. Find an expression in terms of n for the nth term of the sequence. So this is the first time these questions actually got this, okay, this type of question. It basically means you're going to write a rule in algebra. So because it's going up in 4s, that basically means it's involving the 4 times table. So for question A, I'll just put that there. It's going to start off with 4n. Yeah, and the n refers to 1, 2, 3, 4. Okay, right. So it's a 4 times table. 4, 8, 12, 16. However, how is it going from 4 to minus 3, 8 to 1, 12 to 5? What's happening for it in the pattern to get to that? What's being, well, in this case, subtracted. So to go from 4 to minus 3, that is actually subtracting 7, yeah, to get to that. So it's 4n minus 7. It's basically the 4 times table, and then taking off 7, and that's how I'm getting minus 3, 1, 5, 9. So the rule for this pattern is 4n minus 7. That's the rule for this pattern. Right, and that's basic algebraic rule. So I can use that rule then to find any number of this pattern. If I wanted the 1000th number of this pattern, I'll do 4, multiply by 1000, take away 7. If I wanted the 10,000s, I'll do the same. I can find any number of this pattern with that rule, as I want to avoid counting up, because that can take a long time. Right, last question. 2 marks. Here are the first 4 terms of an arithmetic sequence. So similar to before, arithmetic. So we already know, seen that word, it goes up or down the same amount every time. It's always adding 4 or taking away 4 or something like that. So I can see again, really easy, subtracting 4 every time. Then a lot of these questions that I've got lately. So write down an expression in terms of n for the nth term of this sequence. So it's a 4 times table, but then what is happening every time? How you've got to be careful, because it's a minus 4, you're going minus 4n. Right, so how am I going? What am I adding? I'm not going to do all this like the previous ones. Yeah, because it can be quite timely, that one take a while. How am I going from minus 4 all the way to 35? Yeah, what am I adding? So imagine that's minus 4 in temperature. What am I adding to get to 35? And you see I'm adding on 39. Yeah, so I have a minus 4. To get to 0 is 4. And to get to 35, I'm adding another 35. So 35 plus 4 is 39. And that is it. You can also write that, some people don't like having the negative there. You can write that, or 39 minus 4n, yeah? Good teachers in your school will show you other ways to write things as well. Right, that is this live stream today. I have got more in the pipeline. I'm going to go through another paper 3 on SATs, and I'm going to get some more GCSE topics to cover as well. If you're not doing GCSEs yet, doesn't matter. These questions still apply. I've been teaching this to year 7s and year 8s, and other year groups will do it as well, in year 9 and 10. It's all great revision, but it's good to get it in now. Do check out my other live streams. Take care. Look out for posts, and I'm going to do the next one.